Hello everyone, this is our project for course EEE 401. Our project name is Gravity and Interaction. As a part of this project, we have done 3 sub-projects. First one is Newton's cradle. Basic principle of Newton's cradle is whenever we move the first ball to a certain position of h, potential energy EP equals to mgh is stored into it. Whenever we release the first ball, its whole potential energy will transfer into kinetic energy, and with this energy it will hit the next ball and energy will be transferred to the subsequent balls. Whenever it hits the last ball of the sequence, there will be no ball available to transfer the energy. That's why kinetic energy EK equals to half mv square will push the ball and it will reach a position of h from the equation of h equals to v square by 2g, and the process goes on. To make the simulation more realistic, some energy will be absorbed by the balls. That's why the balls are slowly oscillating. But in ideal cases, only the first and the last ball oscillates, other balls remain still. Besides this, we add some air friction to the system.
Our second sub-project is wrecking ball. Here, at first, we design a box with a certain mass and its area of friction. Then we make a certain copies of boxes and place them as a group. Whenever the wrecking ball hits the first column of boxes, we can see that the area of friction of the boxes of the first column is minimum. That's why the loss of given energy is less. But the area of friction of the next columns are higher than the first column. That's why the loss of energy is higher and the boxes move slower. When one layer of boxes moves horizontally, its upper layer boxes want to move with it, but the gravitational force forces it to move downwards. That's why there is a collision between these forces, and the dominant one moves the boxes. Our third sub-project is friction. We know that if we place an object in an inclined plane, it will move downwards due to a portion of its weight, which is mg sin theta. But we know that friction always works against the movement of the object. From the figure, we can see that the movement equation is mg sin theta minus kx is equal to ma. Here, depending on the values of g and k, acceleration value a varies. If we increase the value of k, then the value of a will decrease. And if we increase the value of gravity in the positive x direction, then the value of a increases. If we increase the value of gravity in positive y direction, then the object will just move towards the direction of the gravity. For every sub-project, we have designed a common physical world like this box. In this system, a gravitational field is created. For doing this, we used a JavaScript library. Using this library, whenever we declare any object inside it, gravity and interactions works itself. For input, a mouse controlled event is declared in JavaScript, which helps us to give input such as moving and dragging object in this physical system. Suppose, for example, for the sub-project friction, we have declared two rectangles of different sizes. Between them, one is rigid, which is considered as inclined plane, and the other one is considered as rolling object. Whenever the function is called using this equation described before, the animation takes place. For instance, if we change the angle and friction value, equations are upgraded and animation takes place as follows. Other two subsystems are designed like this one. The user interface and the objects are designed in CSS and HTML5.